Now we are going to see the problems in Bode plots. So the first problem is sketch the Bode plot for the following transfer function and find the value of k for the gain crossover frequency at 5 radians per second. So g of this is given as k into s square divided by 1 plus 0.2s into 1 plus 0.02s. So while you are solving the problems in Bode plot, first ensure g of s contains the standard terms. You know what all the standard term is. Either it may be a constant capital K, or the standard terms may be 1 by s, or it may be s, or it may be the first order term 1 by 1 plus st, or the reciprocal of the first order term or 1 plus st, or it may contain the second order term omega n square divided by s square plus 2 epsilon omega ns plus omega n square, and the reciprocal of this second order term s square plus 2 epsilon omega ns plus omega n square divided by omega n square. So this is the first step. You have to ensure g of s contains any of this. If not, try to convert into a standard format. But here our problem is already in the standard format, so there is no need of conversion, right? That is the first step. Ensuring that first step in Bode plot is to find the frequency response from the given transfer function. So that is find frequency response, that is g of j omega from the transfer function g of s. How do you obtain g of j omega from g of s is that replace s by j omega. Replace s by j omega. So now in this particular problem, let me consider the value as g of j omega equal to, instead of s, we are going to replace it by j omega. So j omega is the whole square divided by 1 plus, instead of 0.2 s, we can put it as j 0.2 omega because we are replacing s by j omega. And the third term is 1 plus j 0.02 omega. Remember guys, in this particular problem, let me consider the value of capital K equal to 1 initially. Later on, I will be finding with the given specification. So this is the first step in Bode plot. Now we'll go to the second step. So in second step, we have to find out the corresponding terms in frequency response. So what are the terms in frequency response? The first term is j omega the whole square. The second term is 1 by 1 plus j 0.2 omega, and the third term is 1 divided by 1 plus j 0.02 omega. From this, try to find out the corner frequency. You know what is the meaning of corner frequency? The corner frequency, this j omega the whole square, that is the differentiator term, so it never contains any corner frequency term, so we can put it as dash. And however, we have 1 by 1 plus j 0.2 omega, so we know that this is the standard format of 1 divided by 1 plus st, 1 plus j omega t. So now tell me, instead of t we have 0.2. We know how to find out the corner frequency, that is omega c1, omega c, that is corner frequency is 1 by t. So here by comparing both these equation, instead of t we have 0.2. So now according to this, the corner frequency omega c1 for the first order system number 1 is 1 divided by 0.2, because the t value is 0.2, 1 by 0.2, so the value is 5 radian per second. I hope we can able to follow this. Similarly, this for this also you have to find out the corner frequency. So this is also the standard format of first order system. So now we can find out very easily. Omega c2 equal to 1 by t2. Here the t2 is 0.02. So 1 divided by 0.02. So the value is 50 radians per second. So this is how we are going to find out the corner frequency. So this is the step number 2. Prepare a table according to the corner frequency. So step 3 is to prepare a table according to the corner frequency. So in the table, it should contain four columns. Column number one is the terms that we consider. Column number two is the corresponding corner frequency. Column number three is the slope rate associated with each of the terms. Then the last column is you have to put it as change in slope. So these are the columns you have to put it in a table. Now we try to accommodate the values. So the terms. So as we know, what all the terms are available here. The first term is j omega the whole square. That is the first term. And the second term is 1 divided by 1 plus j 0.2 omega. 1 divided by 1 plus j 0.2 omega. What about the third term? That is 1 divided by 1 plus j 0.02 omega. 1 divided by 1 plus j 0.02 omega. Now we have to deal with the corner frequency. We know that already we found the what is the corner frequency for j omega square. There is no corner frequency. Similarly, what is the corner frequency of 1 by 1 plus j 0.02 omega? That is omega c1 equal to omega c1 equal to 5 radian per second. So every time we no need to denote the unit. Here also we can put the unit as radian per second. Similarly, for slope rate also, we can put the unit over here, dB per dk. Right. So omega c1 is equal to 5. Here omega c2 equal to 50 radian per second. So now we have to find out the slope rate. So you know that the slope rate for s square is plus 40 because that is available in the numerator. And similarly, what is the slope rate for 1 by 1 plus j 0.20 omega? That is minus 20. Similarly, what is the slope rate for 1 by 1 plus j 0.02 omega? That is also first order system. The value is minus 20. Now we have to find out the corresponding change in the slope. For that, what you have to do? Just you have to make a subtraction. That is for the first one, there is no change in the slope. For here, you have to find out this 40. Here we have minus 20. So when I am putting the change in slope, 40 minus 20. So the value is 20 dB per decade is the change in slope. You have to put it. Similarly, here we have 20. The answer is 20. But here the slope rate is minus 20. So when the change in slope is 20 minus 20, the answer is what? 0 dB per decade. So this is what the change in slope value. Preparing a table, we have to find out the magnitude plot. So step number 4 is to find the magnitude plot. So if you want to plot the magnitude, we need at different ranges of frequency. As we know, omega c1 corner frequency number 1 is 50 radian, 5 radian, sorry, and omega c2 is 50 radian. We have to consider two different frequency, that is omega L, which is lesser than omega C1, and omega H, which is higher than omega C2. Omega L, let me consider the value is 1 radian per second, which is lesser than 5. And we are going to consider omega H equal to 100 radian per second, that is above 50. It is not necessary to assume this 1 radian per second and 100 radian per second. It is up to you. Right? So, but as of now, let me consider both these values. Right. So after this, my job is to find out g of j omega, that is magnitude or gain. The other name of magnitude is gain. G of j omega at the place omega equal to omega low frequency, omega equal to omega L. And the second step, g of j omega at omega equal to omega C1. Similarly, g of j omega at omega equal to omega C2. And the last one is g of j omega, that is magnitude of g of j omega has to be estimated over the frequency omega h. So these are the things we are going to do it. So for this, g of j omega equal G of j omega at omega equal to omega L. Consider the first term. What is the first term? J omega square. Right? So I am going to consider j omega square. So j omega square. For this term, we are going to find the magnitude. If you want to find the magnitude, we will put a magnitude symbol. And since we are in interest to find the g of j omega in dB, we are always put 20 log of them. So 20 log of j omega the whole square. Now, when I am taking j omega square outside the modulus, then the value will be simply omega square. J square gets cancelled out when I am taking the when you are taking j omega square outside the modulus. Then the rest of the value is 20 log. So 20 log omega square. This can be written as 40 log omega because I am taking this 2 into the front. So 40 log omega. Now this 40 log omega, here instead of the value omega, you have to substitute omega L. Tell me guys, what is the value of omega L? Here I have assumed omega L equal to 1. So I am going to substitute omega equal to 1. So let me substitute 40 log 1. So what is the value of log 1? Is 0. 40 into 0 is 0 dB only. So you can verify it. So the next value is g of j omega at omega equal to omega c1. So what is omega c1? My omega c1 is 5 radian. So omega equal to 5. So here for this also you have to use the first term only, since omega L and omega C1 follows the first term only, that we know already, right? So here this 20 log of j omega the whole square, the same term will come over here and the same final answer also will come 40 log omega, but instead of omega equal to 1, we have to substitute omega equal to omega c1. So that's why we are going to find out 40 logarithm of 5. So what is 40 log 5? You know it. So that value you have to find it. 40 log of 5. Now for g of j omega at omega equal to omega c2 and g of j omega equal to at omega equal to omega h, you have to follow a logic called slope logic. So you know what is the slope logic? That is the slope from omega c1, earlier one, omega c1 to omega c2 has to be multiplied by the value logarithmic factor of the current frequency, that is omega c2, and the previous frequency omega c1. Both the value has to be multiplied and you have to add the factor by the gain or magnitude at the previous frequency. My previous frequency here is modulus of g of j omega at omega equal to omega c1. So this is what the formula of slope logic. So now let me find out what is the value of 40 log 5. Log 5 into 40 log 5 is 27.98. So this value, let me put it over here, 27.95. So let me put it as 28 dB. Now this is what the answer. Now what is the slope rate from omega c1 to omega c2? Go back to the table. From omega c1 to omega c2, my slope rate is 20. That is 20, value is 20. So we can change the color. So 20 into 20 log of omega c2. Here omega c2 is what? Here omega c2 is 50. So 50 divided by omega c1. Omega c1 is 5. So 50 divided by 5. This value is added with the previous one. What is the previous one? Right now we calculate, that is 28 dB. So now I will calculate 20 log of 50 by 5. Log 50 by 5 is 10. So what is log 10? Log 10 is 1. So 20 plus log 10 is 1. So log 10 is 1. 20 plus 28 is 48 dB is the answer. So this is what the answer for the second case. Now When you want to find out the g of j omega to omega equal to omega h, same slope logic you have to consider it, but the slope from omega c2 to omega h must be considered, and logarithmic factor of current frequencies omega h and the previous frequencies omega c2, this value could be added with what is the value of g of j omega at omega equal to omega c2 previous one. So that we have to take it into the consideration. Okay. So now I will calculate the values. So slope from omega c2 to omega h is, here the value is 0, right? So here 0 into logarithmic of omega h is, here the value of omega h is 100. So here the value of omega h is 100. So let me put down what is the value of omega here. I can put it as 100. So log 100 divided by omega c2 is 50. Omega c2 is 50. That value is added with the previous one. What is the previous one? 40 dB. Here, there is no need of calculator because 0 into anything is 0. So 0 plus 48, still the answer is 48 dB. So this is what the magnitude calculation. Now, after finding the magnitude, what you have to do is just write down the values like at the frequency omega equal to omega L. We know what is omega L. We have considered omega equal to 1. So what is the corresponding magnitude? 0 dB. So you have to plot the value, like you have to write the value 1 comma 0. Next you have to write down what is omega equal to omega C1, that is 5. At the frequency 5 the corresponding magnitude is 28. So you have to write down 5 comma 28. Then at the frequency omega equal to omega c2, that is 50. So you have to write down the value is 50. What is the corresponding magnitude? The value 50 is 48 dB. So I am putting 48. Similarly, at the frequency 100 also I am having the value is 48. So write down all these values so that it is very useful for you to plot it in semi-log sheet. Finding the magnitude plot, next step is to plot the phase, right? So step number 5 is to plot the phasor values. So phase plot. So if you want to find the phase plot, we have to consider g of j omega equation that we know already. What is g of j omega? That is j omega the whole square divided by 1 plus j 0.02 omega and this one. So just I will write down that value, that is j omega the whole square divided by 1 plus j 0.2 omega, and this is multiplied by 1 plus j 0.02 omega. Now we have to consider the phase value. Now we have to consider the phase. So that is g of j omega in degrees we are going to find it out. So we know that 1 plus j 0.2 omega, that is tan inverse of imaginary part divided by real part. Tan in the imaginary part is 0.2 omega, real part is 1, so I am leaving it. Similarly here, tan inverse of 0.02 omega. Since both the values at the denominator, let me put down the values minus. But here j omega square is coming at the numerator. We know that j omega, the term will induce the phase called plus 90. Similarly, the term 1 by j omega will induce the phase called minus 90. And if there are any terms is coming like j omega the whole square, that will contribute plus 180 degree. Similarly, if it is available at the denominator 1 by j omega the whole square, then it will contribute minus 180 degree. So here we have j omega square at the numerator, so that will contribute plus 180 degree. So this is what the phasor equation. Now, how do you find the value of phase? Now we have to consider the different set of phase. That is, we have to consider the various frequencies we have to consider, not phase. Various frequencies have to be considered for finding the corresponding phase. The phase is g of j omega in degree, right? So what is the value? Yes. So what are the values I can consider? I can consider the values zero point 0.1, 0.5 also I can consider. I can consider the values 1, the corner frequency 5 and 10, 50, 100. So these are the values I can consider it. And you know how to find out this using calculator. Very simply, I told you, right? Using alpha method, how to find out the values I have told you already, right? So you can just use the method and find out the phasor values. After calculating the phase value using calculator, we obtain this, right? So now our job is to plot both magnitude plot and phase plot in a similar sheet. Go to the plotting section, right? So after finding the magnitude plot for the various ranges of frequency and phase plot for the various ranges of frequency, now we have to plot those things into a similar sheet. As we know, we have considered four different frequency, that is 1, 5 radian per second, 50 radian per second, 100 radian per second. The corresponding magnitudes are 0 dB, 28 dB, 48 dB and 48 dB. Similarly, there for the various ranges of frequency 0.1 to 100, the corresponding phase is also we have calculated. Now we will go to Simulak sheet. Now before we are going to Simulak sheet, A, we have to decide the scale, right? So here the ranges of magnitudes are varying from 0 to 50 dB. Okay, so let me give more importance to positive value, right? So that's why let me give the value. So in Bode plot or in Shemilak, if you want to draw a Bode plot in Shemilak sheet, first you have to make a scale, right? So as you know already, this is your point 0.1. So here let me consider this is point 0.1 and this is point 0.2, point 0.3, point 0.4 and this is point 0.5, point 0.6, point 0.7, point 0.8, point 0.9, 1. That's 2, 3, 4, 5, 6, 7, 8, 10 and this is 100. So like this you have to put, then you have to put omega. The value of omega is in the x-axis. The value is what? Radian per second. Similarly, you have to put the y-axis as here I am going to plot the magnitude. So you have to put g of j omega in dB. Similarly, in the right side, I am going to plot the phase value, that is g of j omega in degree. Now we have to decide the magnitude. So here the magnitude ranges from 0 to 48. So let me give more importance to positive value. So here, so let me give, this is 0 dB and this is minus 10 dB and this is 10 dB, 20 dB, 30 dB, 40 dB, 50, 60. So like this I am deciding. Now what I have to do, you have to plot this value. So now what is the first value? 1 comma 0. What is 1 comma 0? Where the point 1? 1 is here. So here the value 1 is here. So value 1 is here. So 1 is here. So from 1, so you have to go for 1 comma 0, right? So 0 point is here. So 1 comma 0 is the first point. And the next point is 5 comma 28, right? So next point is to 5 comma 28. So you have to go to the 5 and the x-axis, and 28 you have to look at. See here the line is this is the line 5. So let me project it. So if you want, you can use the scale. Okay, so when you are drawing manually, you can use the scale. Right, 5 comma 28. So here this is 30, so the 28 point may be over here. So right, so this is the value above 30, right? So this is the second point. Now the third point is to 50 comma 48, right? So here the third point is 50 comma 48. So we have to plot that value also. So the value is 10, 20, 30, 40, 50 and this is 50, 50 comma 48. So here the value is 40, here 58. So 58 to 48 may be over here. So this is 50 line. So the point may be over here. Now the next line is to 100 comma 48. So same value is maintained for 100 also. So we don't need to go for another line. So now this is how we have to draw the magnitude plot. After drawing this, what you have to do is that connect using the scale, right? So you have to use a normal scale. So you have to connect it using a scale. Right. So now we know already from the table, if you want to move from omega L to omega C1, how many dBs you are moving? You have to move the slope rate of minus 20 dB per decade. You have to plot it. Similarly, if you want to move from the omega C2 to omega C1 to omega C2, you have to move with a slope rate of minus 40 dB per decade. Right. Similarly, if you want to move from omega C2 to omega H, then you have to move 0 dB per decade slope, right? So this is what you have to do, right? So this is A, B, and this is C, and this is T. So now the magnitude part is over. So you can give a name called magnitude plot. Now, what is my job is that we have to plot a phase plot. For that also we have a points, right? So we have a set of points for magnitude, sorry, phase plot. Point 1, 179, point 5, 173. So likewise, we have a set of values. All these values I am going to plot it. Yes, point 1, 179. So before that, you have to decide a scale. So here the values are ranges from 179 to 29. So we can consider from 180 degree to 30 degree, right? So 180 degree to 30 degree. So for that, let me consider a scale. So here you try to consider from the lower end. So 30 degree I want. So 30 degree. So you can consider the 20 degree scale. 50, 70, 90, 110. See, remember guys, this scale is not, I mean, constant. You can vary the scale depending upon your requirement. Right, 150 and 170 and 180. Remember, this is a positive scale values, right? So here, this one. Now we have to plot the value. What is the first value? 0.1 comma 179. So what is 0.1 comma 179? So zero point 0.1, you know, 0.1 comma 179. Here 170 and this is 180. So this is the first point. Okay, and the second point is what? 0.5 comma 173, 0.5 comma 173, where the point 0.5 comma 173, 170 is here, so 173 maybe like, it will be like here, right? Sorry, so the point may be here, right? So this is the second point. So this is the first one and this is the second one, right? The third point is 1 comma 167, 1 comma 167, 1 comma 167 is between 150 and here. So this is 167. So likewise, you have to plot all the values. Okay. So 5 for the point, for the frequency 5, 130. For the frequency 5, 130. 5, the value is 130. So it is exactly over here. Similarly, for the frequency 10, 105. For the frequency 10, 105. This is 110 and this is 90. So 10, the value is 105, so it is above 100. So let me mark it over here. So remember, it is an approximate plot only, right? Right. So the value for the 50, the value is 51. So for the value 50, the value is 51. So we can stop it. So 50, the value is 51. So 50 is here. So the 50 is here. So above 50. So I can put it in 50 line. There is no issue, right? So now what you have to do, you have to connect all these lines. So there is what, this is how we have to draw the phasor plot. I hope you guys can able to understand. You have to use the scale value, right? So if you want to give the name, I mean, if you want to use discrimination between phasor plot and magnitude plot, you can give just a name. A, B, C, D we have give already. So we can give E, F, G, H, I, J. You can give like that. Okay, so these are all the values I have plot. So now we have to write down this is phase plot. Now it is over. Now this is magnitude plot and phase plot. Now we have to write down the scale. Scale is y-axis 1 centimeter equal to how many dB? Here we have assumed as 10 dB. And here also y-axis 1 centimeter equal to how many degree in angle? Here I have considered 20 degree in angle, right? So this is what. Now we have problem solved. Is it over? No. See here, this is what finally after doing this, so the problem, I mean the plot will be like this. Okay, so plot will be like this. Now here problem is over. No, see, up to this Bode plot is over, but our problem is here to find the value of k such that the gain crossover frequency is 5 radians per second. What will do? So this is very simple, right? So what you have to do is that take a scale and you have to put a horizontal line over 0 dB. You have to put a horizontal line over 0 dB. Let me make a horizontal line over 0 dB. Okay, so this is a horizontal line over 0 dB, right? So and after that what you'll do is that you have to take a 5 radians per second. I know this is my 5 radians per second. So this 5 radians per second you have to put a line. So this is my gain crossover frequency. Now at the gain crossover frequency, at gain crossover frequency, this is my gain crossover frequency. right? And this is my magnitude plot, right? So at the gain crossover frequency, this is my 0 dB. Now, yes, okay, fine. So this is my 0 dB, right? So now at the gain crossover frequency, the point is crossing, omega g is crossing. Now you have to note it down at the gain crossover frequency, what is the corresponding gain, right? So here the corresponding gain may be for this diagram when without scale I used. So here the value is what, somewhat around 28 dB, right? So the value is what, 28 dB. Just I'm telling the fact, right? So 28 dB. Now if you want to find the value of k, the magnitude value should be 0 dB. If you want to make 28 dB into 0 dB, if you want to make 28 dB into 0 dB, what will do? Normally, what you'll do? You have to just add the value by minus 28 dB, right? So that is what, right? That extra factor you are adding, right? So that is useful to find the value of k. What is the meaning is that extra dB you are adding, no? So if you want to make 28 dB into 0 dB, you are adding some extra value, no, minus 28 dB. That will decide the value of k. That is 20 log of k equal to minus 28. That is k equal to, or log k equal to minus 28 divided by 20, or log to the base 10, right? So now k value equal to anti-logarithm. Minus 10 power minus 28 divided by 10. So k is 10 power minus, say 10 power minus 10. So here the value is 1.2. So somewhat the value is 0.03. So like that you'll be getting. So now k value equal to 0.03, so which is lesser than, which is k value is lesser than, no? So definitely the curve, already we have drawn the curve, right? So magnitude plot with k equal to 1 we have drawn, right? So the magnitude plot with k equal to 1 is shifted down towards the k equal to 1. I mean, it is shifted. Now the new curve is shifted, a new magnitude plot is shifted downwards, right? So because the k value is lesser than 1, so now we have to shift. And at every point of the magnitude plot with k equal to 1, now we have to add the value minus 28. That is what the meaning. Minus 28 dB, we have to add it, right? So now we know that earlier my magnitude plot, the value is 0, 0, 28, 28, and here the value is 48, 48. Already we have the value 0. Already we have the value, that is 0. So already we have the value 0, 28, 48, right? So 28, 48, 48, 48. Now what you have to do? Same frequency, same. Now what you have to do? You have to just add the value minus 28 across each magnitude we have found. Right? So that's all. Now problem is over. 0 minus 28 is minus 28. 28 minus 20 is 0. 48 minus 20 is 20. Right? This is also 20. So now we have to plot the new magnitude with the same frequency. Right? So already we know what is the frequency. Now this is how we have to find the value of k. And we have to draw the corresponding plot. Right? So that's it, guys. So now I will show the final diagram. Now we can see that this is the final diagram for the particular problem. Here you can see that at 5 radians per second, we have drawn the line. So the value is plus 28. But my new curve k equal to 0.03, right? By, we have found out the k equal to 0.03. So now the entire curve is shifted. The entire curve A is shifted down towards by minus 28. Already we found that 0 minus 28 is minus 28. So now, sorry, the value is minus 12, it seems, right? So minus 12. So the value is for point by also they are finding, right? So point by the value is minus 12. Now I am adding the minus 28 by each and every value. So here you can see that minus 28 I am adding each and every point. So which makes the curve, or which makes the magnitude plot down towards the earlier one. So this is how we have to draw the plot. So now we hope you guys can able to understand this. Right? Thank you, guys.